Hello, these are the notes for Lesson 1, Unit 8. In this unit, we're going to be looking at sequences and series. Today, we're looking more at starting with sequences, specifically arithmetic. There are also geometric series. So we have arithmetic and geometric sequences and series. Today we'll be doing arithmetic sequences. All right, so the first is to understand how to write an arithmetic sequence. Okay, these look like this. You have A sub n equals A1 plus n minus 1 times D. Okay, that's what we're working with to start. I will explain what all of these mean. Okay. So let's start with A sub 1. That is the first term. Okay. N, you see A here and A sub n or n minus 1. So n just means the number of each term. If it was the fifth term, you'd have, it would be called A sub 5. Okay. D is your common difference between each term. You must have a common difference for arithmetic, or to have an arithmetic sequence. And A sub n is just the result. In a lot of ways, you can think of this like a function where n is x and A sub n is y. You can plug a value, any value in for n and get a value out for A sub n, or think of it like y. Okay? So you can write sequences in this form where you have an explicit definition, again more like a function, or you can have recursive where essentially you're taking the way you're finding each term is you're adding the previous term, you have the previous term, and you're having some kind of difference to that to get to the next term. Okay, you have to have an initial condition, or A sub 1. Okay, which again, this is the first term. And then some kind of formula. Okay? So this just describes the pattern. It's going to include, you're going to have n sub A sub n minus 1. If the current term is A sub n, the previous term is A sub n minus 1. Okay, so for any recursive formula, you'll have one term, some kind of pattern to get to the next term. Okay, for explicit, you're plugging in the value for n, getting in a value for A sub n. All right. So let's look at some arithmetic sequences. You should be able to tell after 3 terms what you need. Okay? I've got a first term, A sub 1 equals 7, A sub 2 equals 11, A sub 3 equals 15. Okay, so again, this is just saying the first term is 7, the second term is 11, the third term is 15, and it's going to continue in this pattern. That's what these ellipses mean. It's going to continue in that same pattern. All right, so what do we need to know? We need A sub 1, which we have. We need a common difference. So what's that difference? How did I get from 7 to 11 and from 11 to 15? Equals 4. Order or direction matters. It could be plus or minus. It could be positive or negative here. Okay? So we have all we need for an explicit definition. You have a sub n equals the first term plus n minus 1 times 6. That's your explicit definition. I can plug any value in for n and get that term. So if I wanted to find the 20th term, I just plug in 20 for n and figure out what I get. Okay, so let's just try that, for example. Let's say I want to find a sub 20. That would equal 7 plus 20 minus 1 times 6. Okay, 7 plus 19 times 6. All right, plug that into your calculators, or just work it out. You should get 114 plus 7. So a sub 20 equals 121. Okay. All right, let's look at the recursive definition. All right. So we have everything we need. We're writing it differently. Okay. You just write it differently. Now for recursive definition, you need to tell us the pattern and you need to tell us where it starts. All right. So for recursive, a sub n is going to equal a sub n minus 1. Running out of room here. Plus 4. That's my pattern. A sub 1 equals 7. All right, so with recursive, it's harder to find a given term. If I want to find a sub 20, I would need to know what a sub 19 was. And I can't just plug that in with recursive. Recursive isn't like a function. Okay, explicit is much more like a function where I can just plug it in and get a result. I can't do that with recursive. Okay, so go ahead and try the next one, the sequence of 13, 7, and 1. Okay, write the formulas, and for the explicit definition, find a sub 10. All right, for the second one, you see what a1, a sub 1, a sub 2, a sub 3 equal. You find your difference is actually negative because it's going down. So difference is negative 6. All right, so I have my explicit definition. I have my recursive definition. Recursive definition must have the pattern and the initial term. All right, the explicit definition I can use as a function. Find a sub 10. You should get negative 41. Okay. Those are writing definitions for arithmetic sequences. Okay. Let's see if we can figure out if a sequence is arithmetic or not. So you've just got to find the common difference. If there's not a common difference between each term, it's not arithmetic. All right, so let's look at this first one. The difference is 3 between the first two terms, 3 between the second, 3 between the third and fourth, and so on. So I can find the common difference. Is positive 3, so yes, arithmetic. Okay, go ahead and try the next two. All right, so let's look at these. There's not a common difference for either of these other two, so they're not arithmetic. That's as straightforward as it gets. Okay? So let's analyze. And by that we say, all right, we're just going to give you part of the sequence, and you're going to find the rest. Okay? So the first thing you got to do is find the difference. Difference here is 5. I'm telling you it's an arithmetic sequence, so you know there has to be a common difference. All right, so the difference between the first term and the second term is 5. It's going up, it's positive 5. Then I just write my rule, a sub n equals, the first term is 6, plus n minus 1. My difference is 5. All right, so remember, this is an explicit rule, so I can just plug in 50 for n, and I'll get a sub 50. All right. I want to find a sub 50, 6 plus 50 minus 1 times 5. All right, so let's go ahead and work that out. 6 plus 49 times 5. All right, well, 50 times 5 is 250, minus 5 is 245. So 6 plus 245 equals 251. So a sub 50 equals 251. All right. Okay. So try something different. Find the missing terms. Go ahead and try this if you want on your own. I'm going to go through and work it out. This is the last thing we're doing. Okay, so find the missing terms. These are also known as finding the arithmetic means, or the missing terms of a sequence. All right, so I want to find the second and third terms here. I know that A1 is 32. Okay, but I don't know what the difference is because there's no next term. All right, but I do know it's arithmetic. I do know it has to be the same difference between each one. All right, I know that the fourth term equals 11. So between the first and fourth term, it's gone down by 21. Okay, and how many times did I go down? All right, it went down once, twice, 3 times. So it went down by 21 and it went down 3 times. So each time I would just find it went down minus 21 total divided by 3. Okay, that's going to give me a difference of -7 each. Go ahead and try it to check it. Okay, 32 minus 7 is 25. 25 minus 7 is 18. They have a common difference. Okay, and the next one gets down to 11. So that's how you know you did it right. Okay, so that's all we have to do for finding an arithmetic mean or missing terms in a sequence. Okay, make a note of any questions, and we will see you in class.